Okay, in this problem, I've got a steel pipe with a Young's modulus of 200 gigapascals. It's filled with concrete that has a Young's modulus of 24 gigapascals. And what we want to do is we want to find the normal stress in both the concrete and the steel. The pipe has an inner and outer diameter of 80 and 70 shown. So I draw my free body diagram here. I've got 80 kilonewtons acting down on it, and then I've got basically two forces acting up on it. I've got one force through the steel as well as one force through the concrete. So essentially, there's a total of 80 kilonewtons, okay, held by the steel and the concrete. So I have the force through the steel plus the force in the concrete basically equals 80. That's my statics equation. Again, I only have one equation, two unknowns, so I need another equation in order to solve that. That's where I come in with the compatibility equation. And the compatibility equation essentially states that, okay, for this system here, okay, the concrete and the steel have to have the same displacement because of the way that they're connected there. So the displacement of the steel equals the displacement of the concrete. Okay, so what I do here is I plug in the force in the steel and the force in the concrete, okay, times the lengths. Those are the same. It's 500 millimeters, but it doesn't really matter because it's going to cancel out anyway. All over the areas. So I've got the area of the steel, area of the concrete, and then the Young's modulus of the steel, Young's modulus of the concrete. So again, the deflection, the deformation of these two columns are the same because they're rigidly connected to one another. This gives me a second equation that relates the force in the steel to the force in the concrete. So using this equation along with my statics equation, I now have two equations and two unknowns, and I can easily solve those two unknowns. The force in the steel is 57.47 kilonewtons, and the force in the concrete is 22.53 kilonewtons. Okay, then to find the stress, I just take those forces divided by the area. So I've got the area of the steel as well as the area of the concrete, and I can find that the stress in the steel is 48.8 megapascals, and the stress in the concrete is 5.85 megapascals. So again, statics give me one equations, and mechanics of materials is compatibility equation. These deflection equations, deformation equations give me a second. And for this specific problem, the deflections are equal because of the way this is set up and that the way they're rigidly attached. If one compresses, the other has to compress the same amount.